The ocean is a vast and extensive body of salt water on the Earth's surface, connected to oceans, separated, and connected to continents and islands.
The sea plays a very important role in human life, starting from food sources, namely marine biota, transportation, tourism, and energy sources.
Seawater also plays a role in maintaining the balance of marine ecosystems and global climate. However, climate change often occurs and affects marine ecosystems. This is caused by changes in seawater temperature which affect weather patterns. What causes this change? You must have often heard about the term greenhouse effect. What is the greenhouse effect? The greenhouse effect is a simple analogy used to explain the global warming conditions occurring on Earth. A greenhouse itself is a house made of transparent glass material used to cultivate certain plants. Greenhouses are designed to trap the sun's heat so that it does not easily escape, keeping the temperature inside relatively warm. This greenhouse principle is what happens to our Earth, hence it is known as the greenhouse effect.
The greenhouse effect can be defined as the process of warming the Earth's surface caused by the trapping of solar radiation by certain gases in the Earth's atmosphere.
The process of the greenhouse effect is as follows. First, as we know, the Earth's atmosphere consists of various gases. Some of the solar radiation that reaches the Earth's atmosphere is reflected into space, some is absorbed by gases in the atmosphere, and the rest reaches the Earth's surface. Next, the solar radiation that reaches the Earth's surface is reflected into the atmosphere, and some of it is absorbed by the Earth. As a result, the Earth warms up and emits infrared radiation. The infrared radiation emitted from the Earth's surface is partially absorbed by greenhouse gases. As a result, the greenhouse gases heat up and re-emit the infrared radiation in all directions, including back toward the Earth's surface. The presence of greenhouse gases in the atmosphere traps infrared radiation between the Earth's surface and the atmosphere, leading to an increase in temperature. Greenhouse gases are gases that contribute to the intensification of the greenhouse effect. These gases capture and retain heat in the atmosphere.
Examples of these gases include carbon dioxide, CO2, methane, CH4, and nitrous oxide, N2O. Human activities, such as the burning of fossil fuels, can increase the concentration of these gases, leading to global warming. Most modes of transportation used by humans still rely on fossil fuel-powered engines. One example is ships. Ships are frequently used to transport goods around the world. As of January 2022, there were a total of 58,000 merchant ships engaged in international trade. The majority of these ships still operate on fossil fuels, consuming millions of liters of fossil fuels. Imagine the cubic meters of gas emissions produced by the operation of these ships. According to data from the International Energy Agency, IEA, global emissions from international shipping have been steadily increasing each year and are estimated to reach 709 million metric tons by 2025. In July 2023, the International Maritime Organization, IMO, revised its GHG strategy from the previous edition. In 2018, the IMO had set a target of achieving net zero GHG emissions by or around 2050. The revision includes discussions on vision, levels of ambition, and indicative checkpoints to prevent GHG emissions in international shipping. The vision of the IMO is to commit to reducing GHG emissions from international shipping as soon as possible, to eventually eliminate them entirely. This effort is undertaken while ensuring a fair and equitable transition for all parties involved. The level of ambition from the IMO includes the following goals: reducing carbon intensity by further improving energy efficiency for newly built ships, decreasing carbon intensity in international shipping, increasing the use of technologies, fuels,
and/or energy sources that have zero or near-zero GHG emissions in international shipping and targeting net-zero GHG emissions from international shipping.
The IMO's indicative checkpoints are as follows. Reduce total annual GHG emissions from international shipping by at least 20%, striving for a reduction of 30% by 2030 compared to 2008 levels. Reduce total annual GHG emissions from international shipping by at least 70%, striving for a reduction of 80% by 2040 compared to 2008 levels. The targets that IMO aims to achieve include net zero GHG emissions by or around 2050, 5% to 10% uptake of zero GHG emissions fuels, etc. by 2030, and 40% reduction in CO2 emissions per transport work by 2030 compared to 2008.
As a stimulus to reduce carbon intensity of all ships by 40% by 2030 compared to 2008 baseline, ships are required to calculate two ratings: their attained energy efficiency existing ship index, EXI, to determine their energy efficiency, and their annual operational carbon intensity indicator, CII, and associated CII rating. Carbon intensity links the GHG emissions to the amount of cargo carried over distance traveled.
Ships which are designed and constructed today must be more energy efficient than the baseline, thus reducing their carbon intensity. Performance targets are increasingly stringent over time, thus incentivizing innovation in ship design.
There are different goals for different types of ships, recognizing the specificities of different types of ships. For example, the largest container ships, greater than 200,000 DWT, built ere April 1, 2022, must be 50% more efficient than the baseline.
A ship's attained EXI indicates its energy efficiency compared to a baseline.
The attained EXI will then be compared to a required energy efficiency existing ship index based on an applicable reduction factor expressed as a percentage relative to the Energy Efficiency Design Index (EDI) baseline.
The calculated attained EXI value for each individual ship must be below the required EXI to ensure the ship meets a minimum energy efficiency standard.
The CII determines the annual reduction factor needed to ensure continuous improvement of a ship's operational carbon intensity within a specific rating level.
The actual annual operational CII achieved must be documented and verified against the required annual operational CII. This enables the operational carbon intensity rating to be determined. The Indonesian government has issued various regulations and policies supporting efforts to reduce greenhouse gas (GHG) emissions from the maritime transportation sector. Although there is no specific regulation directly referring to the 2023 IMO strategy on reduction of GHG emissions from ships, several relevant initiatives and regulations have been implemented. For example, 1. Onshore power supply. 2. Circular Letter SE from the Directorate General of Sea Transportation of the Ministry of Transportation of the Republic of Indonesia, number 35 of 2019. In the face of a rapidly changing planet, humanity has embarked on a journey to achieve an ideal environmental balance. This quest, however, is not without its challenges.
As we navigate the complexities of environmental stewardship, the shipping industry stands as a critical sector with a profound impact on our planet's well-being. The maritime realm, while a vital artery of global trade, also bears the responsibility of minimizing its environmental footprint. The vast network of vessels crisscrossing the oceans contributes significantly to greenhouse gas emissions, air pollution, and marine ecosystem disturbances. Various efforts have been made by humankind, and various challenges continue to assail our efforts to achieve an ideal environmental condition.
Let us together commit to reducing the negative impact of shipping on our planet. By understanding the importance of energy efficiency and emission reduction, we can create a more sustainable future. Let's take care of our oceans, and let's take care of our planet. Thank you for watching.